All right, guys, final exam time. You are not going to have a unit circle available to you. And I have a unit circle that I use in a lot of the videos that I've been making to help you come up with where's sine equal to this, where's cosine equal to this. But you're not going to have that available to you when you do your midterms and your finals. So to kind of help with that, there's an x and y axis. This video is just going to show you how can I kind of create my own unit circle on the fly, because I'm not going to be able to make those, I'm not going to be able to have one with me on those tests. So first of all, there is my unit circle. Go ahead and mark over here the key points that you have on the x and y axes. This is the unit circle, so remember it's 1, the radius I mean, so 0, 1, negative 1, 0, 0, negative 1. Those are the 4 points on the axes where we hit. Now, then you have your 45 degrees or your pi over 4 radians, okay? And then above and below those, you're going to have your 30 and your 60, okay? So this is 30 degrees, this is 45 degrees, this is 60 degrees, all right? And then in each quadrant, you have those 3 angles, okay? So this is 90 up here, and so to get the other 3, you are doing 90 plus 30, 90 plus 45, 90 plus 60. So you're going to get 120, 135, and then 50 degrees for those. All right, then you got your 180 degree angle right here. That's all the way around. And then your next 3, again, you're adding 180 plus 30, 180 plus 45, 180 plus 60. That's going to be 210, 225, and 240. All right, this is 270. That's 180 plus 90. And then 270 again, add 30, that's 300 degrees, add 45, that'll be 315, and then add 60, and that's 330, and then you're all the way back around to 360 degrees. All right, then your radian measures. So this is pi over 6, this is pi over 4, this is pi over 3, this is pi over 2. Now, going all the way around, one of the things you could do, you are going to have your calculator. So remember, one of the little tricks I taught you guys when you have access to your TI and you want to do this radian stuff is to ignore, this is pi over 6 by the way, ignore the pi's. So for instance, instead of pi over 6, I would do 1/6 and then add that to everything resets right here. So like I did 90 plus 30 to get the 120. Well, I could do pi over 2 plus pi over 6. So pi over 6 plus pi over 2, but again, I'm ignoring the pi. So 1/2, enter, and then math into a fraction. So I get 2/3, but put a pi back there. So this 120 is 2 pi over 3. And I could do that all the way around. I could add 90 degree, pi over 2 radians, which again would be a half, plus the next radian measure is pi over 4. So I would add 1/4. Right, I get that decimal, math, 1 into a fraction. So that's 3/4, that would be 3 pi over 4 would be the 135. All right, and then 150, same thing. Add pi over 3 and pi over 2. All right, and then once I got all those done, I would start at 180, which is pi radians, and then I would add to pi, I would add pi over 6, pi over 4, pi over 3, using the calculator. All right, instead of pi, I would just do 1 plus pi over 6 would be 1/6, enter, math, into fraction. So 7/6, 7 pi over 6. So this 210 is 7 pi over 6 radians. Now, in addition to that, you have to know these points, the x and y coordinates. All right, so here's how I remember those. All right, so I've got a 1 for x and a 0 for y. And then up here, I have a 0 for x and a 1 for y. So you can see my x's are getting smaller as I go down through here, and my y's are getting larger as I go down through here. So the things that are getting smaller, think of it as a countdown, 3, 2, 1. So 3, 2, 1. All right, they're all going to be over 2, and they all have square roots. So square root, and then technically the square root of 1, but the square root of 1 is 1, so I don't need that square root. All right, and so that's going down from 1 down to 0, and then 0 up to 1 is just reverse. It's instead of 0 is smaller than 1, so I'm getting bigger, so I'm counting upward. 1, 2, 3. Again, they're all over 2, right? And then I'm taking the square roots. So again, the square root of 3, the square root of 2, technically the square root of 1, the square root of 1 is 0. So that's these points. 1, 0, this is the square root of 3 over 2, comma 1/2. This is square root of 2 over 2 for both. And this is 1/2. Square root of 3 over 2. I'm sorry about my chicken scratch. I'm doing this with I got writing mouse. My finger, basically. All right, but anyway, there's the first quadrant done. Now, when I flip over to the points in the second quadrant, because I'm flipping over the y-axis, the x-coordinates are going to become their opposites, but nothing's going to happen to the y-coordinates. So what I mean by that is this 1/2 square root of 3 over 2 is going to become a negative 1/2. But the square root of 3 over 2 is going to stay the same because that's the y-coordinate and we're still above the x-axis. So that gets negated, and the square root of 2 over 2, the first one gets negated, the second one doesn't. So that's the kind of the way that I can use the symmetry. I know the points are going to be the same, like the numbers are going to be the same. It's just their signs are going to change. When I flip over into quadrant 3, the x-coordinates stay the same, negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, but the y-coordinates become negative as well. And then finally, when I flip over into the fourth quadrant, you can do it that way. You can also flip this way. The x-coordinates stay the same. The y-coordinates become their opposites. So that's the way that I think of. Basically, everything comes down to getting quadrant 1 perfect and then work from quadrant 1. That's how you can create a unit circle on the fly if you need one. And I encourage you to practice that often before we get to the midterms.